cancer, heart disease, Alzheimer's. These three conditions occur more frequently as we age. Since aging makes us prone to poor health, it kinda makes sense to ask, can we stop it? There are many theories on why we age, listed as the hallmarks of aging. However, one of these may be the root of them all: epigenetic alterations. Epigenetics refers to modifications to DNA that turn genes on or off. However, it does not change DNA in any way or form, just how it is read by our cells. Our epigenetic information, the epigenome, changes over time, allowing it to respond and adapt to its environment. We can compare the concept of epigenetics in DNA to a compact disc. Information stored in CDs are digital and cannot be altered physically. However, the CDs themselves can get scratched, preventing the information stored inside to be read. As scratches build up over time, more and more of the information becomes distorted, causing changes in how the information is interpreted. One of the ways DNA can be modified is by adding a methyl group to specific strands of DNA, a process called DNA methylation. Like scratches on a CD, methylation prevents information from being read by our cells, almost like an off switch. But just like a switch, we can turn these genes back on by cleaning up the scratches that have accumulated. Epigenetics is the reason why our muscle cells differ from our bone cells. Both contain the same DNA, but differ only in their epigenome. The specific patterns and sites where DNA gets scratched give the cell its identity. So, how does epigenetics and our epigenome relate to aging? To put it simply, aging is the loss of information. Epigenetic information. When we lose our memory, it's as if our brain cells accumulate scratches and turn into skin cells. As we age, our organs fail due to the scratches they gain, preventing them from performing their necessary functions. Certain environmental conditions and lifestyle choices such as smoking increases the rate at which we gain scratches, causing us to age even faster. Since epigenetic modifications in our DNA are reversible, we are able to restore the epigenome to a more youthful stage, one where the cells perform their intended functions. In a breakthrough study by Dr. David Sinclair and his students, they discovered a process to reverse aging in mice through Yamanaka factors that are able to revert adult cells to young cells. Using 3 of the 4 Yamanaka factors, they were able to restore the vision of mice, making their eyes young again. These Yamanaka factors act as the polish that clears the scratches that cause us to age, and in the future, we may be able to stop aging entirely.